All right. So I've still been contributing to Tomcat for a while. You heard about that this morning. All right, so first we'll go with a general overview of what Graal is and why it's a problem to use with web apps or generally EE stuff. So the Graal project is developed by Oracle. It's a multi-language JVM, and most importantly, it allows compiling Java executable to self-contained native executables. So the URL of the project, and you have a fancy picture of the Graal, not the actual Graal, apparently. I learned about that watching movies. So how do you fit Tomcat inside a native image? So first, you have Tomcat standalone, which is made of multiple jars. It would be difficult to compile to a single native executable, so that's not a very good fit overall. So as you can easily understand when you think about it a little, is that web apps can't load their classes from normal webinflib or webinf classes, since, well, the Java code compiled into your web apps is like executable code. It will also have to be compiled in the native image, just like the rest of Tomcat. So there's no problem conceptually for configuration file access, reading, parsing, logging, reading static files of web apps, no problem with that. Same for configuration of multiple web apps, virtual hosts. TLS configs are possible also, no problem. So for the packaging, I talked about it this morning, but we have that Tomcat Maven fat jar packaging, which is a kind of a good fit because it will produce a single big jar with everything. And that single big jar with everything, you can compile to a native image, to a single, basically big native binary with everything. So, in your web apps, there's a lot of unwanted things that need to go, or at least pre-processed, to work in Graal. So first of all, I'm going to talk about JSPs since it's included in base Tomcat, but the thing is that any dynamically compiled technology like JSPs would be the same. So first step is to precompile JSPs to servlets, because servlets, well, they are compiled codes then, and that Graal will be able to compile. You can't dynamically compile a JSP, or you can compile a JSP to a class file, but you'll never be able to compile the class binary then, to run the class binary. So then once you compile the JSPs, you have to add the declarations of the servlets to web.xml. So for that, I propose adding using Tomcat web.xml because it's a separate file. So basically, all your precompiled JSPs will go to that separate file. Then all servlet sources and properties files will be copied to the main folder for Maven. All the dependencies of the web apps will be added to the Maven file, and then you'll use Maven to package everything. So that will include the JSPs, the servlet classes, and all the dependencies of your web apps. They'll all be compiled into the fat jar. So the process, how will it work? We'll do a demo, and we are going to base it off the Tomcat examples web app. Basically, why? Because it has a bit of everything. It has servlets, JSPs, expression language use, WebSockets, and we are going to use Tomcat native OpenSSL as well. We're also going to use JSSC to see what works and what doesn't, basically. So this is a step-by-step demo, and at the end, we're supposed to have a native image, a big binary, with the examples web app and Tomcat, obviously, to run the examples web app. There's a Tomcat documentation page on Graal support with the instructions. There's also a wiki page, I think. Okay, so first we're going to use Tomcat Maven. So what do we have in Tomcat Maven? So we have some Docker file packaging for container packaging of the resulting big fat war and the native image. We have that Ant script for the web app packaging. Basically, it's a web app JSP precompilation mostly. So the pom.xml, it uses the Maven shade plugin to package Tomcat, the web app classes, and the dependencies into the big fat jar. I have a YAML file also for the container deployment plan. It could be useful at the end. I'm going to do a demo with Kubernetes, hopefully, if I have time. And you also have weird JSON files in the Tomcat native stuff, which is basically some base descriptors for Graal. The descriptors contain reflection information and all sorts of things, which I'll talk about right after. So Tomcat Maven, which you'll get in the Tomcat source tree. It's in Raise Tomcat Maven, basically. And so it contains these files. So I'm going to take these files and put them in my main demo folder, which will be my main work directory from now on. All right. So I've copied all Tomcat Maven for stuff into my demo folder now. All right. Next. So the thing is that the packaging is actually very similar to Tomcat standalone. You'll be able to use the bin folder, which is the default Tomcat native location. I'm going to take advantage of that. You can use the conf folder. Basically, you can put there all your Tomcat configuration files that you would otherwise use, like server.xml. So I put in certificates, but we'll actually use the key store here, and login config as well. The usual stuff. So source main, it's all the Java sources that you would want to have compiled into the fat jar. You can add your stuff at this point here, no problem. Web apps, well, it's just like regular Tomcat. That's the default app base for the default host. So web apps, your web apps can go there. And work, you have the default Tomcat work folder. All right, so what we'll do then, I have prepared some configuration of that thing. So I have my bin folder. It has Tomcat native because that's handy. My conf folder, that's the usual configuration files. So login properties, server.xml. Server.xml is almost the same. So what I'm going to do, basically I disabled some problematic listeners here, like the memory leak prevention listeners and all that sort of stuff. That's it uses reflection and you won't run with Graal because it uses Java internals and the same issues won't apply to Graal anyway, so you don't need these. So I removed them. If you noticed, you have the usual user database with Tomcat users.xml as usual. It's almost the same as the default config, except that I added two SSL connectors. I have one with OpenSSL, and I have another one with JSSC. Both use the same key store. It uses an RSA key. And in both, I enable HTTP2. On one of the connectors, HTTP2 will not work. We'll see why. So I also added, the default engine, no problem. I added a clustered configuration based on Kubernetes. Basically, it uses a cloud membership service with Kubernetes REST API. So that's the default database realm. I put in a health check valve. It's not really needed. I haven't configured in the health check in the YAML, but well, just to show it works. And then there's the usual access log. So nothing special. All right, so I'm going to copy now all these files, except that listener. All right, so I'm copying here. All right, so extra stuff I have SunnyC. It's a shell library from Graal. It's meant to implement elliptic curve. I'll talk about that later again, but well, it's needed basically. So in web apps, I have the actual, the default Tomcat web apps, no surprise. That's the example web apps I'm going to run. All right, so packaging. All right, so we need to process the examples web app now. So let's start the process. Let's see. Need to switch to my demo folder first. Okay, so next I'm going to compile the main Tomcat fat jar. Okay, so it's built with Tomcat 9.0.27, which is the latest. Yeah, I preferred using the latest with that because there's always last-minute fixes, you know. So then I'm going to actually precompile the web apps with the packaging script. So it's pretty simple. That compiles the default the examples web app. Yes, that was the examples web app. For ease of use, I'm going to package. Oh, it's just a script which precompiles, but it runs fast. Yeah, I'm going to compile the root web app also. And then the manager web app, you know, just in case we want to show that it's working. All right, because there's JSPs in the manager web app, like to show the sessions and things like that. So dependencies. So I need to add the dependencies of my web app to the main POM. If you know Tomcat and the examples web app, you know there's JSTL dependencies for that web app. So basically, you need to add that dependencies to the POM. So let's do that. No, it's not here. Okay. So pom.xml, yeah, so I'm going to add that dependency here. All right. Yeah. Okay. All right, so I added my dependencies of the web app. Basically, you'll see, because if you go to web app examples, webinf lib, you have these jars. So since Graal won't be able to use or compile this jar, you have to give it to him another way, basically. All right, next. Okay, I have a little extra listener I'm going to add. I'm going to explain why. So next we are going to do the Graal reflection setup, because basically any class you load dynamically in Graal, like you do class for name, needs to be declared beforehand. So Graal knows how to compile this thing and wire up to the color class, basically. So you need to file up all this JSON descriptor. You don't want to do it by hand, so we are going to use a tool. So for that, we are going to start the substrate JVM, which is basically the default mode for Graal, with a tracing agent, which will trace all this reflection and dynamic class loading. So basically, either we can access then all the classes which need to be dynamically loaded, like servlets, JSPs, WebSockets, or we can just load on startup, because if you load on startup, servlets and JSPs will get loaded on startup. So Graal will trace everything. Note that it will work for servlet and JSP, but it won't work for WebSockets. So basically, at this point, I need to manually access WebSocket endpoints to make sure they're loaded and they are seen by the agent. When that's done, you need to add resource bundles. Like basically, it's your internationalization. It's not automatic, unfortunately. I don't know why, but it's not automatic. Some interfaces aren't traced properly for some reason, so you have to add them manually. And generally, you need to add anything that will get picked up. You'll notice later when you get an error, essentially, and then you know when to go back. So let's restart the process. So at this point, I'm going to add a load on startup listener. I'm going to show the code. It's very simple. Let's see. Yeah, that's its listener. So what it does, basically, it's a Catalina lifecycle listener, and it sets load on startup to every servlet so that it makes sure they're all loaded on startup. Okay. So I'm going to add that in source, main, Java, util. All right. So these other classes are all stuff from the example web app or precompiled JSPs. So you have a lot of stuff in there. So at this point, we are going to build the whole thing. We are going to do Maven package again, and this time it will have everything. So Maven package, all right. So it compiles all the precompiled JSPs and everything, so it went fast. All right, it didn't crash, that's good. All right, so you'll see you have a rather big Tomcat Maven jar here with everything. I'm going to show you what it has exactly. So if you open it now, you see all these classes from the examples. Here in the examples or Apache JSP, like you have all the precompiled JSPs. And besides that, you have all Tomcat. That's all Catalina. So everything's compiled into that jar now. So I then need to add a few extra things. Oh no, I'll just start. All right. So now I'm going to run the Graal substrate VM. That's my Graal installation path, by the way. It's just the VM used here. And at this point, you see you're just using a regular command line for Tomcat, except that it has a tracing agent, like native image agent, and it will set the output for its trace file into that tracefile.json. So we run that. Takes a while to start. It's Java, so it takes a while to start. I have an exception. Why? Because that's my Kubernetes thing, not finding its service account token, so it's okay. It's all right. It's normal error here. So everything otherwise started up. The two connectors, everything's good. Let's access stuff. All right. Let me see. So that's the default welcome, no surprise. So then I'm going to access some the same thing to HTTPS. It will use HTTP2 at this point. I didn't get the certificate warning because I did it before, basically. So see, I put in debug trace for HTTP2, so yes, that you can see it's actually using HTTP2. But the uncool thing is that if you're using the JSSC connector on the other port, see, I get the certificate warning here. Okay, I accept the risk, I sign it myself. It's not, it's using HTTP2 as well, all right. No, it's not using HTTP2, that's normal. All right, so as you can see, the other connector isn't using HTTP2. Why? Because Graal only does Java 8. So it doesn't have ALPN support, so no HTTP2 basically. That's a major problem for Graal at this time. So we have traced some items for the. I need to trace a few more things because I wanted to demonstrate WebSockets. So I'm going to go to WebSockets to see the multiplayer snake. All right. So that uses a WebSocket endpoint to do stuff. All right. So. Okay, so I've done it. All right, so when you're done exercising your web app, you can kill your JVM and move on. Okay, so I'm going to generate the config files from the trace. Basically, what it will do at this point is that it will take the trace file.json and generate multiple individual JSON for each sort of item. Like there's one file for reflection, one file for JNI. And at this point, I'm going to add the resource bundles for the example web app to target resource config.json, which was just generated right now. So it's here. I'm going to add it here. All right, yeah. So why? Because unfortunately it's not traced by the agent. So if I don't do that, I'll get errors loading my internationalization resource bundles, which would be a shame because it's a stupid error, obviously, at this point. So at this point, you're all set. You can run native image. So. Well, obviously it's not going to fail here, but for you and your own web app, many errors can occur, like Graal won't find some resource, some class loaded dynamically. He won't like what you're doing. Something is missing. Some incompatible library is messing things up because, well, he's doing things like that Graal doesn't like. That I don't know, start a thread in a static initializer. Just giving an example, using JMX, whatever. Anything can happen, really. So code may need to be fixed a lot. And if it fails, you need to go back a few steps back and, like usually, redo some descriptors and all sorts of things. So we are going to run the native image now. That's a big thing, basically. That's a big item, all right. So that's this command line, all right. So what does it do? It's not that complex, actually. It has a few things that cause problems with static initializer in Tomcat. It has the URL protocols used by Tomcat, HTTP, HTTPS jar. That's not by default, so you need to specify it. No server, it's to allow compiling multiple times without crashing. HTTPS, you need it for TLS. That's for the configuration descriptors you've just generated. And the last parameter is the Tomcat Maven jar. That's a big fat jar with all the classes. So let's do it. It's going to take 1 minute, approximately. So at this point, if you have a question, we have 1 minute. No. JDK 11 support in Graal. It's a top priority item for Oracle, but they're still working on it. They don't give any dates for Graal, except they have a release train, basically. So every 3 months, you get a major Graal release now. So right now, it's 19 for 2019, 2, I think, and you'll get 3. And, well, it will go on from there. And you get no support unless you buy the EE version. Oh yeah, by the way, there's a community edition of Graal that you can download freely, and then there's an enterprise edition, which is commercial. The community edition works very well. It's just a little bit slower, like the EE edition, I've noticed like it's 10% slower, faster maybe, or more, like 5 to 10, let's say. So it's nice, but it's not the end of the world. I guess they do more inlining and more stuff because the binary generated by the EE edition was bigger, so even more inlining. So I say even more because the binary is already pretty big, so so it's pretty, well, it's big enough already. So all right, it's done. So what happened? I have my Tomcat Maven executable. See, it's only 55 megabytes, about, yeah. 54 something, so it's pretty big. But it has everything from Tomcat and everything from the examples. So I can do a quick example and run it. All right. So the arguments, the same as the regular Tomcat. I have my logging config file. If you'll notice, there's one thing missing. It's the log manager because it's incompatible with Graal. So no Julie log manager. You have to use the default Java util logging log manager with Graal. Otherwise, you get the Catalina base, and well, you just run it like you would for a normal executable. So boom, it started. You didn't wait, you didn't do anything. So basically, what do I have? See that web app, like the docs in 3 milliseconds, but I wanted the examples. Oh yeah, so the examples web app, which is pretty big with all servlets, takes I don't know, 48 milliseconds. If I try the other one with it was with the native image agent, like it was more. So that's the difference. So yeah, it was, I don't know, 700 milliseconds. So, all right. So next we are going to for a good comparison, we are going to put that in a container and run it through Docker because we'll be able to really compare the two of them very easily. So let's go to Docker now. All right. So I did the testing. I'm going to pass my slides. Okay, so in a container now. So you're going to build the container image. All right, so I've noticed you get an executable, so you don't need Java. So basically, you can base off a container image which doesn't have Java. So you can use BusyBox, for example, and you need some adjustments, but you get the Docker file. Basically, instead of the shaded jar, you need to pick up your executable. It's pretty basic packaging. And unfortunately, you can't use Jolokia or Prometheus for monitoring since you don't get any JMX. So the problems you are going to run into is TLS support. Basically, you need that SunnyC library. Unfortunately, it's only a dynamic library. It can't be compiled as a static thing, so you need it. Also, you have Tomcat native, which has plenty of dependencies, which are annoying. And the thing is that there's an option for static linking for Graal to generate a native image. So you compile, when that's enabled, it will compile the standard library and zlib as static libraries. But unfortunately, it will only compile that statically. It won't compile Tomcat native or SunnyC. The problem is that they're always going to be missing if you're going to use TLS. So that's an issue in Graal for the incomplete static linking capability. Basically, we would need to be able to configure additional libraries to be compiled statically. As a result, the host platform must be the same as your target platform. You can't cross-compile, to some extent. For example, I can't build a static native image that will run on BusyBox with TLS support because of missing SunnyC and Tomcat native. I tried, it's not possible. So you need to either run a container that is based on Fedora, like my desktop, like my laptop, or forget about TLS. So that's not cool. So the packaging, what I recommend at this point is use the same base image as the host OS. So this way you'll be able to use TLS. So then you add OpenSSL, APR, SunnyC, and Tomcat native libraries to the container image as needed, like your base image. Like for example, I'm going to use Fedora, it has OpenSSL, so I don't need to add it. I still need to add APR, and I'll add SunnyC and Tomcat native. So then I use my example Docker file to package everything into my container image. So it's a good idea to test using Docker first before deploying to clouds or everything. That's the next step, all right. So I'm going to build now my Docker stuff. All right, so that's the regular image. Okay. Oh, I'm not in the right folder. All right. Yeah, I switched too soon to the root folder. What was it? It was demo. Yeah. No, work. Demo. All right. Let's try again. So that's a regular container image from the fat jar. So since it's a regular jar, I'm using Jerry Alpine from OpenJDK. It's a small container image with just OpenJDK and Alpine. It's the most size efficient Java image you can get, I think. I tried to find better ones, but they're less supported. So I've built my first container image. We can see it here. Here. In my Docker containers. Here, that's the one I just built. All right, so next I'm going to build the same, but with the Graal executable. So you see the process. It's going to take a bit more because it's going to pull stuff up from the internet. Hope it works. So I'm adding SunEC here, which is a shared library for elliptic curve. And I'm installing APR from Yum using DNF. So it's going to wait for a while until it downloads the dependency. Hopefully not too long. I can take questions in the meantime, if you have any. No. Okay, let's wait. Elliptic curve, well, otherwise you won't be able to use the advanced ciphers for TLS. And basically, you'll get JSSC support, no problem, but you won't be able to connect to anything without elliptic curve, because all the ciphers will be disabled. I mean, all the usable ciphers will be disabled. So you need... Yeah. Oh yeah, you won't be able to handshake without that. Oh, it's pretty obvious. I mean, you get an error on startup that it doesn't have SunEC, so it disables stuff, and then it doesn't work. So it was already pretty limited because it's Java 8, so JSSC is a bit limited, and that basically cuts off the rest. So it's installing APR, so that's done. And then it's going to add my binary for Tomcat native. Okay, that's a fat binary. That's configuration files. That's the web apps. So just set the work, dir, whatever. Okay, it sets a Kubernetes environment. Okay, and that's done. Okay, so I have my second. So as you can see, it's a lot bigger. It's 500 megabytes because it's based on Fedora 30. I had to use my my host image, basically. So I'm going to run this and see how it goes. Okay, run. So it's starting. All right. Run. Yay. And while it's going on, I'm going to try to start my OpenShift in case it works. All right. It will take a while, so I'm doing it in the background. All right. So both Tomcat containers seems to be both containers seems to be started. Oh no, it started that. Ugh. Horrible. Okay. So basically, what you can see is that you have your Docker container here. That's for the native one. Takes 35 megabytes of RAM. If you go back, the regular one takes 400 megabytes. That's the Java one. So that's a pretty big difference already. So you can then access your container, the container, and see how it runs. So what do I have? Docker containers. Yay. So that's the IP for my container. I think I copied it here. So I can access it. That's the Graal version. So it runs just as normal. So I'm going to run the WebSocket example, or maybe I can run some JSP. So I have some, for example, the EL example. So it runs just as usual. So I'm going to run the WebSocket snake, which I just loaded. And so I have demonstrated WebSocket functionality, JSP, EL, and obviously servlets just right there. So I can see the server status. Oh no, I have access denied. I need to configure the users. Instead, I will access no. I will access HTTPS. Okay, so it runs just as usual. And I'm going to verify it used, yeah. See, it actually used HTTP2 properly. So everything is functional, Tomcat native works, JSSC works, but it won't use Tomcat. It won't use HTTP2 in that case. It will just connect using HTTP 1.1. So basically, everything is functional. The TLS configuration with your key store, HTTP2, WebSockets, JSP, EL, everything works fine. But it uses a lot less memory. So I'm going to stop these containers now and try to do the same with OpenShift. Stop. All right. So where's my OpenShift going? Oh, it's going okay. Starting up. So now deploying to cloud. That's the most fun part. So we can start a local OpenShift cluster like I did. I'm using the Fedora OpenShift packages, so it's OpenShift 3.11. And then I'm deploying to the image to the local cluster, to the local cloud. I'm using the YAML I showed. And then I'll test again. Okay, that will be the answer prize, basically. All right, so what do I have? So did OpenShift start? Yes, OpenShift started, so that's good. And then I'm going to deploy with that YAML, which is basically saying to deploy that container, which is the Graal one. Sorry. Okay, so let's open my OpenShift console now. Okay, so I'm going to import the YAML with my superb container. Where is it? Okay, demo, Graal, yay. All right, create. Okay, so I'm going to create a first pod, which is not starting. Oh, it's running. I don't know why it showed up at not running initially, that's odd. All right, it's fine. Good. All right, so you can look at the startup logs, and here you won't get the error about the Kubernetes cluster because it's enabled. Like you see, the HA cluster, the Catalina cluster is started. Tribes support, Tribes is there. And you also get, like, I don't know where, but you're going to get like the members being added as well. Normally you're supposed to get the first member, but apparently it's not there. Oh well. Yeah, you'll see them when you add some more pods, which I'll do. It will fail, but I'll do it anyway. So let's see. So I'm going to access my container again. So it's still working just fine. So I don't know why it does that. I think I forgot to configure my user here. Anyway. Okay. Okay, and the last thing I'll do now is I'll access the cookies example. It's just another thing that's working. So basically that creates a session and it sets like a cookie in the browser in the session. So the thing is that I'm going to add pods, and I'm going to show that the cluster is working. Unfortunately, as you can see, session replication is not working because of missing Java serialization. It's not implemented in Graal. That's this issue. And so it's going to fail to replicate the session, but at least it's going to discover the other nodes, and otherwise seems to work. Let's see. No, that's not the one. Okay. Need to go there. And so I'm going to add more pods. The thing is that you'll see how quickly it scales to 4. Basically, there it deploys the pods, and then it will start them, and it's very quick, actually. If you try that with the Java stuff, it will take forever. Oh, it takes forever. Oh, no. It's probably my laptop, anyway. It was fast. It was fast on my desktop, but anyway, I'm running 4 Tomcats in parallel with the same thing now. So we are going to show what happened, basically, in the logs. So it still starts pretty fast, in a matter of milliseconds. And it detected the other members of the cluster. So that's all we are going to get at this point, because if I try to refresh here, still works, but it will fail to replicate the cookie. Oh no, it's working, but I don't remember where I can see the failure, but I saw it. Basically, it will fail to with a not implemented exception. Yeah, maybe that's a good idea, but I'll try to access another host. I think 3 is going to work, yeah. Now, see, it didn't replicate the session here, and I think the error is going to be in the log. No, it's not in that one. Okay, let's see, pods. Let's see my logs. No. No. It's actually pretty good. Well, anyway, it can't replicate the session data. That's why it didn't replicate the thing. I don't remember which path shows the session problem, but yeah, it doesn't work. All right, so I'm done. I demonstrated everything, including cluster functionality on Graal. So as far as I know, everything is more or less functional on Graal, except for the documented problems, which are mainly TLS, which is sketchy, and serialization, which is not implemented. So the benefits, as you could see, the startup time is more than 10 times faster. The memory use is very low, at least initially. And it means that in most cases, I mean, unless the web app startup time is really long, but I think in most cases, on-demand services are possible if you're allowed to sacrifice 50 milliseconds for a first request, basically. It works very well as a small container image, if you don't need TLS mostly at this point. I really hope all these 2 major issues in Graal are resolved sooner rather than later, you know. And it still looks like a normal Tomcat, like you get your conf folder, the web apps are the same. Basically, I made no modification to the web apps except packaging. So, however, as you could see, you need a lot of work to test and set up. The tracing agent isn't very user-friendly. You could use Java libraries which aren't Graal compatible. You could ask the libraries developer to know about that. So, in addition to serialization and TLS, which is limited, you have no JMX. I really don't like that because I like JMX for monitoring. And it might not be that beneficial if you have a large high-load server, like if you have a high-load server with 100 web apps. I don't think you want to go through that process. And also the startup time benefit will still be there, but the memory use you'll see if you actually bench the Graal native image, the memory use will swell and will be just as big eventually as the hotspot one. So you won't get any memory benefit on the long run. And I'm done. So, any questions? You all good? All ready to... All right, Rainer?
Will Java thread-dumps work?
Will Java what?
Thread-dumps. Kill minus quick.
Trend-dumps. I haven't tried actually. That's a good question. I don't know. I'll have to try. Actually, I didn't generate it. I didn't try it because usually I do it with JConsole. And I think, yeah, they now bundle a special JConsole version with, sorry, with Graal. And I think you can try that one. I don't know if I can pipe a signal in there. Oh. No. PS? No. Yeah, it's a limited. Yeah, you need to add packages basically. So, yeah. Oh, yeah, there's skill. There's skill, but yeah. No. Mm. Oh. Which one is it? 107 maybe? One? Really? No, I think it would be 107 my own. Really? Okay. So it's kill what? Minus what? Minus 1? Okay. Let's see what it did. No, I did nothing here. Nah. Yeah, it's the same. I clicked on the same, but yeah. So I don't know. You'll have to check. I'll check it anyway, so. That was a good question. Yeah, I didn't try the, well, it's not JConsole, you know, it's a virtual VM. I think that's a bundle. I haven't tried it yet, so.
JConsole might also use JMX to get the thread.
No, it doesn't use JMX. It's a special one which doesn't use JMX. There's no JMX at all, like, nothing.
Yeah, I know, but in the old world, there is two ways to get the thread dumps. There is MBS
Yes.
and there is the signal handler. So
Yes.
I don't know what the new JConsole, it might be a feature that got removed due to
Yes.
ambience.
Basically, I always use JConsole and Ambience and JMX to get my thread dump, so. Oh well. Any other question? Yeah, over there. I'm not going to hear you without the mic, I think. Oh, me. I don't know how the garbage collection works. I've noticed it worked based on memory, but I don't know how they implemented that. I'm not a Graal developer, so you have to forward that to their mailing list, maybe, because, well, I haven't looked at the implementation details of Graal at this point, except some bugs that I was interested in, because I ran into bugs at some point. I tried to build it. It's pretty difficult to build already, so it's not a very welcoming open source project. It's semi-open source, basically. If you're interested, it's in GitHub. It's Oracle Graal. Going to show the path, hopefully. Oracle Graal, yeah. There it is. So that's there. And to build it, you have to use a JVM CI8 JVM. That's a special JVM implementing some whatever into compiler interface or whatever. some weird stuff, and then you have to build some tool also, and then you'll be able to build the substrate VM, which is the interesting part. And then you'll be able to use your native image once you build it. So it's pretty difficult to build yourself, but in Las Vegas, actually, I did this presentation and I built my Graal myself. I think I'm done, so if you have any other really quick question, otherwise we are done. No? All right, thank you.